All right, so we're going to work on using logs to solve exponentials. So previously, we've only solved things that had logs in them, right? So maybe the usefulness of logs were a little bit lost because we were sort of forcing them to be there in the problem. But now we're going to see how logs can be useful to us to solve problems that previously wouldn't have had logs and use them to specifically solve exponentials. We can do this because logs are an inverse of exponentials, and so we can use them to sort of pull things out of the exponent and then use that to solve for x. So we'll look at a couple of examples here, and then I'll have the packet that we're working on this week to you. So this will be example 1. So we've got 2 times 15 to the x minus 3 equals 16.8, right? Now, if we wanted to try and guess what x was, we could try and figure that out. But ultimately, if we try to solve for x here, if we try to guess what x is, we're not going to be able to get it. It's a random decimal number that comes about through using some logs, and so we could sort of make a guess at it, but ultimately we're not really going to be able to figure out what it is unless we actually solve for it, right? And to actually solve for x can't be in the exponent like it is here. It needs to be out of the exponent. So one way that we can do that is by using using logs to pull exponents out of the exponent because of the power of a power rule, right? But before we're allowed to even pull anything out of the exponential, we need to sort of get the exponential by itself. So I need to get that 15 15 raised to the x minus 3 by itself. So to do that, I'm going to divide both sides by 2 just to get the 2 out of there, right? And so when I do that, that'll give me 15 x minus 3 is equal to 8.4. So I'm making myself a little bit more room here. 8.4, right? Now, at this point, we've got the exponential all by itself, right? 15 raised to the x minus 3 is all by itself, and the other side has been simplified to 8.4, okay? Now, what I can do is I can take the log of both sides, and I'm not going to do log of 15 or log of 8.4. I'm just going to do a common log, okay? And the reason for this is we're not actually going to be able to evaluate these logs in our heads. We'll have to use calculator to evaluate these logs. And so if I'm totally allowed to do log of 15, right? Whatever I do to one side, I can do to the other. But if I do log of 15, then I'm going to have to go back and use the change of base formula anyway to convert it to common logs. And so we may as well just solve it using common logs as it is, right? So I'm going to take the log of both sides. Basically, whatever's on either side is going to become the inside of a common log. Okay. What that does for me is now that this is all in the log, I can bring out the x minus 3 because that's an exponent as a multiplier out front of my log. Right? I can bring that out as x minus 3 times log of 15. Right? Is equal to the log of 8.4. Okay. Now you might be tempted at this point to plug it into a calculator or evaluate those logs, but we don't want to do that because if we do that now, we're going to lose decimal places and then lose accuracy in our final answer. So we want to keep things as logs until we get to the final answer, right? But the thing we need to remember is that each log is just representative of a numerical value, right? It's equivalent to 10 to whatever power, right? That would give us 15. So 1 point something, right? And that's not particularly useful to us at this point in time. I don't care about what the value of log 15 is, right? I want to know the exponent. So I don't really care what log 15 is. So I'm just going to move log 15 around as if it's a number. And what I mean by that is I can divide both sides by the log of 15, right? And so what that does is it cancels out log of 15 on one side, okay, leaving me with just the x minus 3. Okay. And on the right, now I've got log of 8.4 over the log of 15. Okay. So still, again, some value, but I don't really care. It doesn't really matter because it's still not useful. So the last thing I need to do to solve for x is to add 3 to both sides. Right? And so finally, I'm left with x is equal to the log of 8.4 over the log of 15 plus 3. Now, I know this doesn't necessarily feel like a very satisfying answer in that it doesn't seem like it has a whole lot of value, but if you don't have a graphing calculator, this is the way that I'm going to suggest that you leave it, because we want an accurate answer, and this is as accurate as an answer is going to get. I know it doesn't feel like that, but we haven't had to round this at all. We haven't had to cut off any decimal place, so this is perfectly accurate, and we can still plug it into a calculator, so I'll plug it in so you can sort of get an idea of what the value of that is, and it'll be about 3.76, 786, 3.786. And so if I plug in 3.786 to my original equation, right, it should be approximately equal. Now, there's obviously more decimals going on, but we chop it off there, right? So ultimately, if you don't have a graphing calculator, you should be leaving your answer here. Really, the main takeaway here is that we can use logs to isolate an x and solve for it. So let's do one more together, and then I'll let you go. So here will be example 2. And really, the only thing that's going to change here is there's going to be sort of an extra step. So negative 3 times 4 to the 8 minus 4x minus 5 equals negative 29. Okay. And so we've got our exponential right here. We're trying to get that by itself, so I need to get rid of the minus 5 and get rid of the times negative 3. So I'm going to start by just adding 5 to both sides. Okay. If I remember when I'm solving, we're sort of undoing PEMDAS. So I want to undo addition first, and then undo multiplication, and then undo exponents. And that's sort of the reason that I choose to go about it in the order that I do. So negative 3 times 4 to the 8 minus 4x equals negative 29, sorry, not minus 5, plus 5, because we add 5 to both sides, which would leave us with negative 24. Okay. Now we're going to divide both sides by negative 3 to get rid of the negative 3, okay, which will leave me now with the exponential all by itself on the left side, so that's good, right? One step closer to getting x all by itself. And on the right, negative 24 divided by negative 3 is a positive 8, right? So just like above, when I got the exponent all by itself, or when I got the exponential all by itself, that is when I pulled out the log. So exponential all by itself, so I'm going to log both sides, right? So inside becomes a log, inside becomes a log. Okay, this is just an operation, so I can do it to both sides. It doesn't affect anything. So when I do that, my exponent, 8 minus 4x, comes down to the front, right, leaving me with 8 minus 4x times the log of 4. You have to forgive my handwriting, over log, or is equal to, sorry, log of 8. Okay, so now we'll divide both sides by the log of 4, just trying to get that log of 4 away from the x, right, trying to get x all by itself, which will leave me with 8 minus 4x equals log of 8 over log of 4. Okay. Still remembering that I'm trying to undo PEMDAS, I'm going to start by subtracting 8. Okay, so I've got 2 more things to do. I need to subtract 8 and divide by negative 4. I'm going to start by subtracting the 8. Okay. Oh. So now negative 4x equals log 8 over log 4 minus 8. Okay, and finally, we're going to divide by negative 4 on both sides. Let me change my color scheme a bit here. I'm just going to leave that as right? And we'll divide by red. There we go, negative 4, right? So all of that divided by negative 4. So for my final answer, you sort of have a couple ways. You could leave it as it is right there. So negative 4 is just dividing everything. Okay. Remember that our goal would be to eventually plug this into a calculator. So as long as you understand what that means, that's good. Alternatively, another way you could go about it would be to write this as negative 1/4, right? Because dividing by 4 is the same as multiplying by negative 1/4 times what we would have otherwise been dividing by, right? So that's a possible solution. The one above is good. If you were to plug this into a calculator, you get about 1.625. Right. So sort of maybe an answer. Maybe it means something to you. Maybe it doesn't. But again, we want probably, unless you have a graphing calculator, to leave our final answer as what you see above there. So in the email that this is with, I'll have attached the relevant, what's the word I'm looking for, packet for the week, and I'll have some more videos throughout the week, but this should give you a good amount to work on tomorrow.